All right, sixth grade. So we're moving on today here into chapter 9, talking a little bit about input-output tables a little bit. Also, this kind of thing here that you see with an oval and the arrows, this is what we call a mapping diagram. And when we talk about input and output, we're relating these to ordered pairs, where the input is the x value, the output is the y value. And as you know, an ordered pair is always written xy, as we've done that with a coordinate plane. So all this is kind of building up to that a little bit. So the first set of directions, we have 3 today, that say describe the pattern in the mapping diagram, copy and complete the diagram. So when we talk about the patterns that are taking place, essentially what we're doing is we're looking for a pattern that's talking about what's happening to the x value, what's happening to the y value. Now sometimes, depending on what the values are, okay, there could be a very succinct equation taking place. If it's a linear equation, that's a whole different topic, but for another day. But basically, when we talk about a pattern, we're looking for a pattern in the input column, a pattern in the output column. Then it wants you to actually copy the whole thing down and fill in the missing ones. So my pattern for x, I would see, well, x is increasing by 1. So I would actually write that down on my paper. X is increasing by 1. And I would actually write that down on my paper. Now for y, I see that I'm going, well, 1, then 7, then 13. Well, I know that 1 plus 6 is 7. I know that 7 plus 6 is 13. So I'm able to see that y, or my output, is increasing by 6. So that would be my y input. So now to actually describe the pattern, I'm going to copy all that down, and then I'm going to have to fill it in, these missing blanks here. Well, 13 plus 6 is 19. 19 plus 6 is 25. 25 plus 6 is 31. So that's all you're doing on the first part, those first 3 problems. 3 through 5, that's what you're doing. Now the second part gives you a completed mapping diagram, and it says to list the ordered pairs shown in the mapping diagram. Well, the arrows, okay, we didn't talk too much about the arrows the first time through, but the arrows from the input to the output, now we don't want to forget that the input represents our x value along the x-axis. That's the first number in the ordered pair. The output is the y value. Remember, a coordinate plane, we have the y-axis that goes vertically. We have the x-axis that goes horizontally. So the x indicates how far left or right. The y indicates how far up or down. And an ordered pair is written as the x-coordinate, a comma, and then the y-coordinate, the whole thing in parentheses. So it wants to list the ordered pairs shown in the mapping diagram. Well, the arrows signify what number goes with what. Now, I want to point something out. And this would be kind of a non-linear sort of a thing because there's not a pattern with a clear equation with what's going on. So we would kind of find that this is not really a line here in these ordered pairs, but this would be how our ordered pairs would match up. And you're going to have non-linear functions and linear functions, and that's all is in your math future. But for what we want to focus on right now is, well, what would the ordered pair be? Well, I see that the 1 from the x goes over to the y for the output. So my first ordered pair would be 1, 8. Okay? Well, my 2 goes an arrow to the 4. So my next ordered pair would be 2, 4. Well, I see my 3 goes up there to the 6, 3, 6. So I would have 3, 6. Then from the 4, I'd go from 4 to 2, and I see that my ordered pair would be 4, 2. And then I would have 5, 2, and I would see that my ordered pair would be 5, 2. All right, and those would be my ordered pairs. Now, I want to point something else out, and this will become important in the third part of what we're about to do. And that's when I list the mapping diagram, I always put my input values from least to greatest, okay? And then I put my output values either from greatest to least or least to greatest, whatever will get them the least amount of crossing of lines. You can't always minimize all crossing of lines. But if I would have started with my 2 up here, I would have had these 2 coming way up here, my 1 coming way down here, and I would have had a lot of crossing of lines going through there, and it's harder to understand. So when you're making a mapping diagram, you have to decide with your output values, are you going to have less crossing going largest to smallest, or if I was to reverse these. And in this situation, you're definitely going to have the least amount of intersecting lines going from greatest to smallest. Input value is always least to greatest. That doesn't change. This is what gets adjusted for the lines. Input is always least to greatest. All right, now, so let's look at the third part of what we're doing. All right, so here we go. Now, the third part is going to say draw a mapping diagram of the set of ordered pairs. So I'm going to say, well, okay, I'm going to look at my different ordered pairs here, and the ordered pairs are going to give me our 1, 3, 5, 7, 8, 10, and 14, 16. All right, so I'm kind of seeing, well, okay, kind of seeing what's happening here. And so I'm looking at drawing a mapping diagram. Now I'm starting to see a pattern here, and I'm seeing that some are getting skipped. Okay, so I want to point something out. We talked about patterns with the X and the Y. Sometimes on an ordered pair, you have to realize that there's a lot of points between that. So even if these numbers don't show up as a specific pattern, okay, there is a pattern, because I could see 1, 3, and then I would go 2, 4, 3, 5, 4, 6, then here's 5, 7, then 6, 8, then 7, 9, and then 8, 10, then 9, 11, 10, 12, 11, 13, 12, 14, 13, 15, 14, 16. And they're all in there. It's a continuing line. So I'm going to see a mapping set. So I'm going to go ahead and make my input X, output Y. All right. And I'm going to go ahead and make, okay, my things. I'm going to go ahead and put my input down from least to greatest, 1, 5, 8, 14. And then I need to say, okay, well, my output values, 1 is going to go with 3, 5 is going to go with 7, 8 is going to go with 10, 14 is going to go with 16. So I think I'm just going to keep it as 3, 7, 10, 16, because they're in least to greatest order. And 1 would go with 3, 5 with 7, 8 with 10, 14 with 16. So there'd be no crossing at all. So I'm going to go ahead and go 1 to 3, 5 to 7, 8 to 10, 14 to 16. Make that a little bit better. There we go. 14 to 16. And there I have a mapping diagram. Now, want to point something out. Because depending on the ordered pairs, you might have to go greatest to smallest. You might have to cross lines. You may have the same output for the same input. How this is 4-2 and 5-2, you notice that we only put 1-2 there. And we just draw 2 arrows to that 1-2. We're not going to put a special 2 for the 4 and then another special one for the 5. We're not going to do that. There's just going to be 1-2 from the 4 to the 5. So kind of a different sort of lesson, 6th grade today. I don't think you're going to have too much of a problem. I'll be available to help during the class for this assignment. So we'll talk to you later. All right, bye.